All right. I want to look at a couple of these together. This is a review, but we're going to do a couple of them together and just get our minds right before we move on today. So we're on page B. The first question, it asks you to state the domain and the range. Now, remember yesterday, it is in alphabetical order. So domain comes before range and X comes before Y. So your domain are your X values and your range are your Y values. The best way I know to keep that straight is, like I said, they're in alphabetical order. So all you have to do for the domain is just list them out. All right, I see -2. -2, I don't have to write it a second time because I've already listed it. I see -2 again. I see -2 again. I only need to write it one time. So the domain for number 1 is -2. The range are your Y values. Now, I'm going to highlight my Y values just because it's not wrong, but it looks better if you put them in order from least to greatest. So of those yellow range values, the smallest would be -9. Next, we would have 0, and then 3, and then 5. Now, in terms of notation, do not put parentheses around the domain or the range. This is not an ordered pair. It is not an interval, okay? So don't put parentheses around there. All right, you would do number 3 the same way, but I'll leave that one for you to do. Let's look at number 18. I want to look at this one right here. This is a quadratic equation. That's what we're getting ready to study today, a little bit later, is how to graph a quadratic equation. But this is a quadratic equation, and that's kind of the beginning. All right, let's talk about domain. We just discussed that domain are the X values. So if you look at this horizontally, this is your domain. Your domain goes from left to right, and that's never going to change. So if we are to look at this downward U, this is a U. It's a quadratic equation, also known as a parabola, and it's been flipped down. But now notice it has arrows on it. These arrows are very important. This means it's going to go forever in the left and the right direction. So if it's going forever to the left, to the left, to the left, to the left, and it's also going to the right forever. Now it is pointing down, that's true, but it's also getting wider and wider and wider and wider. As it goes down, it gets wider and wider and wider in the left and right direction. So what would your domain be? What x's is this graph going to cross if it continues going forever? Negative infinity to positive infinity, because it's going to go to the left forever. This arrow means it continues going forever. And it's also going to go to the right forever. So every x is going to be contained. Now, let me show you, let me just draw you on the board a model of this. So right now, we see something that looks kind of like that, hypothetically. But the arrows tell me that it's going to go on forever and forever and forever. So it's going to go forever and forever and forever and forever and forever. Now, what mathematical number is to the left forever? Negative infinity. Good. So it's going to go to negative infinity on that side. And then it's also going to go to the right, to the right, to the right, to the right, ever so slightly for all eternity. And the mathematical number for that is positive infinity. So the domain, not the range, but the domain is negative infinity to positive infinity. Now, let's look at the range. I'm going to change colors. The range is the y values. So we're looking at the y-axis. This right here is your range. You look at the y values for range. Now, we learned yesterday you always go from the bottom, okay, here's the bottom, to the top. That's how you read range. So the lowest it's ever going to dip to the highest it's ever going to reach. All right, let's go to Jaylee. Jaylee, if these arrows indicate it's going down forever, what is the lowest bottommost number this thing's ever going to reach? Negative infinity. I agree with her. And we're going to put a parentheses because we know parentheses always go with infinity. All right, and then we have to go up to the top. So if we go up to the top, now remember we're looking at our y because we're talking about range. Jaylee, what is the, this is not grammatically correct, but what is the toppest most y this quadratic is ever going to reach? 0. Now, we have to decide, and this goes back to our interval notation, which we've been studying since September. We have to decide if 0 gets a parentheses or a bracket. Well, let's look right here. Jaylee, do you see an open circle there? No. So it's going to be a bracket because it actually touches at 0. All right, we talked about, what was, Keeson, the little analogy I gave you yesterday for increasing and decreasing? What's the little real life application story that you can use to discuss increasing and decreasing? Yes, you do. You remember it. You ride this at the State Fair, Disney World, roller coaster, okay? Now, you always sit on the ride on the left. So you would sit down on the roller coaster over here, and you're going to ride the ride basically for all eternity. But we noticed that, okay, when you start, what's your body doing? Going up, right? It's increasing. And then, something happens right here. Now, this is this 3? I can't see the graph paper very well. I think that's 3, right? Isn't that at 3 on X? Okay, so at 3, something happens. We have a turning point at 3. Because from 3 to the right, what does your body do? Goes down. It's decreasing. So I don't think we did one yesterday like this where half of it is going up and the other half is going down. Now, think about a roller coaster, okay? Think about the sounds that a roller coaster would make if it had this shape. So you know what it's going to do. It's going to start going real slow. Click, 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 click. What is going to happen for 1 milli nanosecond? It's going to stop. When you get up to the top of that roller coaster, you're going to have that brief second where you can see everything around you and know how crazy it was that you got on that ride to begin with. Now, after that millisecond passes, what happens? You go straight down. But there is a moment in time, it's called a turning point, where your body is neither increasing or decreasing. Now, remember from yesterday, I told you this, but we're going to talk about it a little bit more now. The turning point occurs at the X, not the Y, and you always use parentheses for increasing and decreasing. The reason is, at the turning point, which occurs right here, you are neither increasing or decreasing. You cannot increase and decrease at the same time. That's not possible. Think about your English word, increase, decrease. It's either increasing or it's decreasing, or it's staying the same. But it can't increase and decrease at the same time. So that's why go ahead and put yourself 2 sets of parentheses for increasing and decreasing. And the reason that we put parentheses and not a bracket is because you cannot possibly increase and decrease at the same point. It's called a turning point. All right, now we start at the left. And what is the mathematical number for the left? Negative infinity. That is correct. So from negative infinity to 3, we are increasing. So for increasing, put negative infinity to 3. No, you use your X coordinate. Go back to your notes. That's what I just said. The turning point occurs at the X coordinate, not the Y. So our X coordinate here is 3. Our turning point is 3. You use the X coordinate, not the Y. That is very confusing. All right, and then at 3, it starts doing what? Decreasing. So from 3, now what number comes after 3 and means for all eternity? infinity. It's positive infinity because even though it's going down, it's also going to the right, and the right is positive infinity. Now, we're getting ready to study quadratics today. They're going to look like that. We probably won't get to one that's flipped today, but we are going to study quadratic equations. And quadratic equations, I'll give you some hints. They always have a domain of negative infinity to positive infinity because they're always going to look like this. They're always going to open up to the left and to the right for all eternity, or they're going to open up like this for all eternity. Increasing and decreasing, notice that these are kind of flip-flopped. So from negative infinity to 3, it increases, but 3 to positive infinity, it decreases. And this is your turning point. This is very important. Your turning point is what you use for increasing and decreasing. It's the x value, not the y, and that's very confusing to people. All right, let's try 17. We haven't done one like 17. Zamarian, what shape is 17? Is it a function? No, it doesn't ask this question, but this is not a function because it would fail the vertical line test, because it fails the VLT. That is not a function. We studied that yesterday. It is a thing, though. Entire course of Math 172 is circles. The first day you walk in the class until the end of the day you leave the class, you're talking about a circle. So it is a mathematical object that we can study. It's just not a function. Okay, Destiny. Let's look at our domain. Remember, the domain goes this way. This is your domain. You're reading this graph from left to right if you want to know the domain of the circle. So, Destiny, what do you think the domain of this circle is? Look at the circle to the furthest left point of the circle and to the furthest right point. And where would those points be? Wait, this is the furthest left point of the circle. Right here is the furthest left point, and this is the furthest right point. So what is this? Is it -3? I can't. Okay, I think it is -3. Okay, so everything from -3 all the way over to what? +1. And Destiny, you got to put it in the correct order. -3 comes before +1. And do we put brackets or parentheses there, Destiny? What kind of circle is this right here? So we bracket because it's a closed circle. All right, so that is our domain.
Always put a bracket for circles?
For circles, yeah. Yeah. But the reason we put a circle, hold on, let's not say we always put a bracket for circles. The reason we put a bracket is because I do not see an open circle. So like hypothetically, if we were going to do 19, do you see any open circles there? No, so it's going to be brackets. For 21, it's a triangle. Do you see any open circles? No, so it's going to be brackets. It's not about what shape it is. It's about whether or not it's an open circle or a closed. All right, the range goes from the bottom to the top. So the lowest you can possibly go to the highest you can possibly go. This is the range. The range comes from the y-axis. So let's go to Ava. Ava, what is the lowest this ever dips on the y-axis? 0. Good. What's the highest it ever reaches?
4.
Do y'all agree with her that that's 4? I can't see the blocks. They're too small for me. Okay, 4. And then, Ava, based on what I just told Zamarian, are you going to put parentheses or brackets?
Right.
Thank you, Ava. It's going to be brackets because it's not an open circle. All right, let's do 2 more at the bottom of the page. Let's do these 31 and 33. Is it a function, yes or no? All right, 31 is a circle. Now, we just left a circle problem where we were asked to state the domain and the range, but that's not what we're asking here. All they want to know is this a function, yes or no? Okay, JC, Is number 31 a function? Tell me yes or no. No. Very good. Why not? Good. Because it fails the VLT. Now, on our test, it's going to ask you yes or no, and you're going to have to tell why. So all you have to do is say no because it fails the vertical line test. And there's a million different examples of where you could see that that happens. But the 31 is not a function. It doesn't mean it's not a relation. It does not mean you cannot write the equation. It does not mean it's something we can operate with. It just means it's not a function, and that's okay. We can still work with it. Okay, number 33. Same thing. We're going to use the vertical line test. Ariana, do you see anywhere on number 33? This is an unusual shape. We haven't studied anything like this. But do you see anywhere that my vertical line would cross that graph more than one place at a time? No. So is it a function? Yes. It is a function, and the reason is that it passes the VLT, the vertical line test. It is a function because it passes the VLT. All right, let's flip to page C. I want to look at the last two on page C because these are harder than any we've ever done. So we're going to look at page C. I want to look at these two shapes right here. We have not done one that had a two-part graph. So these two were on page C, and these have a two-part graph. And we're going to do these two, and then we're going to stop and move on to another topic. All right, let's look at, I don't think I have these numbered. So let's look at this one down here. All right, domain. This is a little stressful, so we're going to have to take our time here. Remember, the domain goes in this direction. This is your domain, and you're going to read it from left to right. So let's go to Johan. Johan, now notice we have arrows. We actually have 4 arrows on this one because it's a two-part graph. All right, Johan, what is this doing forever to the left? Okay, negative infinity. I agree with him on that. Okay, so I'm just going to kind of hold that thought right there. All right, Johan, and what is it doing to the right? Going to positive infinity. Now, that sounds nice. I'm tempted to just put negative infinity to positive infinity. But I see a little issue here. I see that it looks like it's going to come towards this line but never cross it. It looks like it's going to avoid that highlighted line. It looks like to me it's going to come close, 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 close for all infinity and go down forever. But it looks like it's never going to cross the yellow line. Now, in a couple of days, we'll learn the equation for this graph, and we'll know a little bit more about why this is true. But for today, it looks like it comes from negative infinity and almost touches what? What would that yellow line be for the domain? No, it's going to be 0. 0. It looks like it comes almost to 0, and then it looks like it goes from 0 to positive infinity. Do y'all agree with me that that's what it looks like it's doing? Now, I did freehand these, so it's not perfect. All right, so let's write this as a domain. It's going to go from negative infinity to 0, and then it's going to go from 0 to positive infinity. We know we put parentheses. I hadn't finished. We got to put our brackets, parentheses, and a union sign. But if it never crosses 0, in other words, it gets close to 0, but it never touches it, do I want to put brackets on these zeros or parentheses? Parentheses, because it never touches. And remember from our last test, when you have a two-part interval, so in other words, it's going to come from negative infinity and approach 0. And then it's going to come from 0 and approach positive infinity. What do you put in between them to unite the two intervals together? a U. So let's put a U. We want to have 2-part interval. All right, let's look at our domain. Our domain is similar. I'm sorry, our range. We just did domain. Our range is similar. We know we're going to go from the bottom to the top for our range. This is our range in purple. Let's go to Carmen. Carmen, what does this thing look like it's going towards in the bottom direction? Negative infinity. I agree with her on that. We know infinity always gets a parenthesis, so I can go ahead and put that there. And then Carmen, what does it look like the highest it's ever going to reach might be? -1. I agree with her. Now, I free-handed this, so it's a little bit hard to see. I look like I hit it right here, but I meant to come up and look like I was this is perfect over here where I'm getting closer and closer and closer to -1. All right, Carmen, do you think it's ever going to cross -1?
Like go past -1?
Yeah, past -1. No, so we're going to put a parenthesis there. All right, let's talk about our domain. I'm sorry, our increasing and our decreasing. Isaac, which side of the graph do you always start the roller coaster on? The left side. So we're going to start over here because this is the leftmost point. Here's our little guy sitting in the roller coaster bucket, and he's going to get on that ride. And Isaac, for all eternity, what is his body going to be doing over here? Going down. I agree. So this is decreasing. So let's do that part. Decreasing. All right, Isaac, if you sit to the left, what is the numerical equivalency to the left forever? Now make sure you're putting it down here because this is where it's decreasing. So -infinity to, now Isaac, remember, let's go back to our notes. Remember, because this is something Carmen asked about, the turning point occurs at the X coordinate, not the Y. It occurs at the X. We've already decided that our X was 0. So from -infinity to 0, it's going to decrease. How do I know to put a parenthesis there with that 0?
You always use it for increasing and decreasing.
Very good. You always use a parenthesis for increasing and decreasing. A number cannot be both increasing and decreasing at the same time. Yes, ma'am?
Why would it be 0 if it's not touching that line?
Because it's going to approach 0. That's why we don't put a bracket, because it never actually reaches it. But it attempts to go from -infinity, and it gets closer and closer and closer and closer and closer and closer and closer to 0, but it never touches it. For all infinity. Yes, sir?
If it touches -1, you're always going.
Well, he's saying, why didn't we put -1? You could argue that I drew this wrong. You could argue that. But since I'm here talking to you today and I'm telling you that I meant for it to try to get to 0, it's just that I didn't draw it very well. That's my fault. So this is approaching 0, not -1. All right, now let's do the other side. We have 2 rides. So this time, your little guy sits down over here. This is still a roller coaster, and he still sits down on the left. But Isaac, what's he doing for this half of the graph? He's increasing. This side is increasing. He would be going up. Now, increasing and decreasing have the same turning point. So if I use 0 for decreasing, I'm going to use 0 for increasing. Now, Silas is saying that my drawing does not look like it actually touches 0. It looks like it's approaching -1 and +1. And that's probably true. You're probably right because I free-handed it. But trust me when I say if I had continued this, I meant for it to approach 0. That was my heart's desire. I just didn't draw it very well. All right, so Isaac, from 0 to the right, and what's the right? Infinity, it's going to increase. All right.